All right, good morning. Welcome back to Applications of Calc 2. We have a volume of revolution of, I think this is a negative here, uh, a function that looks like the square root of x, e to the negative x over 2. We're going to revolve this about the x-axis. So we are going to think about how this work looks, something like this. Okay, I wouldn't expect you to graph it, but we're going to go ahead and revolve it around the x-axis. We're going to take our radius squared times pi, and that's going to be our, and times our height, which is all these things, all these dx's that we're adding up. You will have a problem like this on your exam. You do have to memorize this formula for how to do it, which just means we're going to square the radius and then integrate and then multiply by pi. Okay, I believe this went from 0 to 2. We'll go ahead and check that out. So the first thing you have to do with this is this is a problem that has you deal with properties of exponents. So when I square the square root, okay, that's nice that something happens, that the square root disappears. Thank goodness, that makes this an easier problem. And then when we have an exponent raised to an exponent, we multiply the two exponents together. So x over 2 times 2 is just e to the negative x. And we're just going to go ahead and integrate this between 0 and 2. And then you say, oh, look, it's a polynomial times an exponent. This means we have integration by parts. And I'm glad you guys see that. So we have let u equals x, du equals dx, dv is equal to e to the negative x, v equals negative e to the negative x. Just integrating this. Do I have all of my pieces as far as my dv takes care of my e to the negative x dx? Yes. And my u equals x. All of the pieces of the integrand are used up when we're dealing with this. And then we just go ahead and deal with our integration by parts formula. So we're going to get negative x e to the negative x. I just swapped the order, right? Instead of uv, I said vu. It's not a big deal. Minus the integral of negative e to the negative x dx. I just kept the negative sign there for a moment. Almost always the first thing I do is go ahead and just add, and we have integral of e to the negative x, and we just go ahead and integrate that. Okay, so we have negative x e to the negative x minus e to the negative x. We're just integrating this piece here, and then we're going to evaluate this from 0 to 2. One of the things that I like to do, because I hate negative signs, is pull this negative out, and we're going to say this is x e to the x, all right? Just on the baseline, just these negatives, this not the exponent negatives. Okay, and we have 0 to 2, and I'm going to say this is equal to x e to the negative x plus e to the negative x. And instead of going from 0 to 2, I'm going to go from 2 to 0. Swap the order of integration, you change out the negative sign. This makes things, to me, I think it makes it a little bit easier to kind of sort out what's going on. Let's plug in our 0. We have 0 times e to the 0 plus e to the 0, right? Negative 0 is still 0 minus, and we have 2e to the negative 2 plus e to the negative 2. Okay, so that's what we're trying to figure out here. Put that in parentheses. So we actually end up with 1, because 0 times e to the 0 is going to be 1. We have e to the 0, which is 1, minus, and then we have 2 plus 1, right? If I pull out the e to the negative 2, we have 3. 2 plus 1 is 3. E to the negative 2. The whole of this thing, when we have to finish it, is times pi. Remember, that was way up here. So like one of those things where I just kind of drag the pi all the way down through the entire problem. Don't forget it's there. Okay, all the way down until we are finally ready to put this back in. Get out your handy dandy calculator, and we'll go ahead and see. I just have this little one here. We'll just type this in as 1 minus 3 second function e to the negative 2. Okay, and then I got pi times this thing. So I have pi times 0.53, 593 rather, 593, we'll say 5940. We'll do that to 4 decimal places. Multiply it by pi, ta-da. And then we have 1.86, 1.8661. We'll call that good. Okay, that's how you do a problem like that. Again, the whole, like, I'm asking two things or three things at one time. One of those things is Do you remember your rules of exponents? And then, of course, can you apply integration by parts when you are in a situation where it isn't explicitly told that you have to do integration by parts? Can you recognize when you have to use it? Anyway, thank you very much for watching the video. I'll see you in the next one, and good luck, everybody.